Energy-producing processes in the universe, including nuclear and optical processes. Energy generation is a fundamental process that occurs throughout the universe, powering the stars, galaxies, and other objects that make up the cosmos. There are two primary processes by which energy is generated in the universe: nuclear processes and photonic processes. Nuclear processes involve the fusion or fission of atomic nuclei, which release large amounts of energy in the form of radiation and particles. One of the most important nuclear processes in the universe is the fusion of hydrogen nuclei into helium, which powers the stars and produces the energy that sustains life on Earth. The fusion process occurs in the cores of stars, where the high temperatures and pressures allow hydrogen nuclei to overcome their natural repulsion and combine to form helium. This process releases a tremendous amount of energy in the form of light and heat, which is radiated outwards and provides the energy that sustains the star. As stars evolve, they can undergo other nuclear processes, such as the fusion of helium into heavier elements like carbon and oxygen. These processes release even more energy and can result in the formation of new stars and the creation of the chemical elements that make up planets, asteroids, and other objects in the universe. In addition to nuclear processes, photonic processes also play an important role in energy generation in the universe. Photonic processes involve the emission and absorption of light, which can release energy in the form of photons. One of the most important photonic processes in the universe is the process of radiation, which occurs when charged particles emit photons as they accelerate through a magnetic field. This process is responsible for the emission of radio waves, gamma rays, and other forms of electromagnetic radiation from a wide range of objects in the universe, including pulsars, black holes, and active galactic nuclei. Another important photonic process in the universe is the process of thermodynamics, which involves the conversion of heat energy into work. This process occurs in a wide range of objects, including stars, planets, and other celestial bodies, and is responsible for the production of heat and the regulation of temperature in these objects. In addition to the processes of nuclear and photonic energy generation, there are other important sources of energy in the universe, including gravitational potential energy, kinetic energy, and thermal energy. Gravitational potential energy is the energy that is stored in an object as a result of its position in a gravitational field. This energy can be released when the object falls towards a massive body, such as a star or a black hole, and is converted into kinetic energy as the object gains speed. One of the most important sources of gravitational potential energy in the universe is the accretion disk around a black hole. As matter falls towards the black hole, it releases gravitational potential energy, which is converted into thermal energy as the matter heats up and emits radiation. This process is responsible for the emission of powerful jets of radiation from active galactic nuclei and other sources. Kinetic energy is the energy that an object possesses as a result of its motion. This energy can be released in the form of radiation or other forms of energy as the object interacts with its environment. One example of kinetic energy release in the universe is the process of supernova explosions, which occur when massive stars reach the end of their lives and collapse under their own gravity. The collapse releases a tremendous amount of energy in the form of kinetic energy, which causes the star to explode and release a burst of radiation and particles. Thermal energy is the energy that an object possesses as a result of its temperature. This energy can be released as radiation or other forms of energy as the object interacts with its environment. One example of thermal energy release in the universe is the process of star formation.